Okay, guys, here we go. These will be some of your instructional videos. Okay, these are going to help you understand the material. My time with you is inconsistent. So, for some of you, you're here. You're here maybe one day a week. Well, I'm filming this, it's January 4th. Okay, so I don't know what it's going to look like by the end of the month. Okay, I'm hoping we're here. Hoping we're here. Hoping we're getting to a point where we can be here all the time. But I got to be prepared. Okay, so here are some of your instructional videos. You are expected to take notes on this. When I say to pause the video, you're expected to pause the video and try the problems, okay? I can't always be there to hold your hand, all right? So, we're going to start in Chapter 2. Chapter 2, Section 1, functions in their graphs. Before we can even talk about functions, we talk about relations. And a relation is a mapping or pairing of input values with output values. Okay? Input values, input are X, output values are Y. Those are letters that you're familiar with dealing with. Okay? When they ask you to find the domain, okay, to find the domain, this refers to your input. This refers to X values, and we think of it as numbers we can plug in for X. In our range, okay, our range is our output and our Y values, and if these are the numbers that we plug in for X, these are the numbers we get. Okay, these are the numbers we get. When you plug in this for X, this is what you get, your range. Okay? So any mapping. So you could have something like this, an XY chart where 1, 2, 1, 4, 1, 5, negative 1, 6. This is a relation. Okay, that is a relation. Okay, now any mapping of X's and Y's, you might have it written this way, where we have 1, 2, 3 for X, and over here we have negative 1, 4, 7, and it shows how we have our mapping. X's go with Y's. Okay? This is different. This is more specific. A function, okay, a function, or let me start off differently there. Okay, a relation is a function. A relation is a function, provided there is exactly one output for each input. One Y for every X. Okay? So when we look back at this one, where I have an X that goes to 3 different Y's, this would not be a function. No function there. Okay? Each X has to go to exactly one Y. So if I had an XY chart where I had 1, 2, 2, 2, 3, 2, 4, 2, this is okay. This is a function. Why? I have only one X value. Okay? And each X value goes to one Y value. So even though they all have the same output, it's still a function. Still a function. Okay? If I had this, 1, 2, 3, 4, 5, 6, 1, negative 1, this is not a function. Not a function. And the reason it's not a function is because I have one X that goes to 2 different Y's. If you have an X that goes to 2 different Y's, it's not a function. So when we're dealing with functions, when we're dealing with relations, one thing that's very helpful to understanding them is if you can create a graph, okay? Pictures help you, okay? If you're trying to put something together and they send you just a paragraph, okay, of directions, it's harder. It's easier when they provide pictures. You can look at the picture and you can figure out how to do it that way. Well, math is the same thing. And a lot of times our pictures are graphs. So we have this thing that's called a vertical line test. And a vertical line test is something that we can tell if something is a function or not. Okay? So it says a relation is a function if and only if and only if no vertical line intersects the graph at more than one point. Okay? So, if I had picked a graph of a circle, is it not a function? And it's not a function because if I made a vertical line, it would hit my graph in two places. If I had a parabola that opens up, this is a function. Because no matter where I draw my vertical line, it's only going to hit my graph in one spot. If I had this, which is, this is what I have, y equals x squared. This is x equals y squared. We're not going to study it in this course. But if you had this, this is not a function. Because 1x has two different y's. So this would be not a function. Okay? All right, so we don't have that much more in this section. It's one of the shorter sections. We're probably going to do some graphing in here. Okay? Graphing helps. Again, gives you a picture. So if you have this, we are used to this. Y equals x plus 1. Okay? And now we have something that's called function notation. Function notation. It's really the same as this. It's just written f of x equals x plus 1. This is a more sophisticated way of writing it. Okay? You will see this in higher level math. Okay? Higher level math, you will see f of x in replace of y. It means the same thing. It means the same thing. Okay? And it's read, this is read f of x. That's how you read it. Okay? And then they're going to talk about different types of functions. Okay? Different types of functions. So let's say I had f of x equals x plus 7. This is a linear function. One reason why it's a linear function, if you graph it, let me start over. Its graph is a line. That's one reason. The second reason it's a linear function is because it fits the y equals mx plus b4. Okay? So that's another reason why that's a linear function. You can tell by its graph, you can tell by matching it up with y equals mx plus b. Now if I had this, a little bit of this, and a little bit of that, f of x equals x squared plus 2x plus 1. This is a quadratic function. Okay? Quadratic function. And what makes it quadratic is right there. The y equals x squared. It fits that pattern. Its graph is a parabola. Okay? So that covers a lot of the notes in this section. We are going to do some practice problems. Okay, some practice problems that I want you guys to do. I want you to do it right in your notes. I will be looking for this when you turn your notes in, making sure that you have the practice problems there as well. And I'm going to give you a couple of problems to do. Write this down for you. Okay, there's one. And here's two. Okay. Here are your directions. Here are your directions. So number one, is the relation a function? Number two, I want you to list the domain and the range. Okay? And I think that's it. I think I'll be good with those directions. Domain, range, and tell me if it's a function or not. Okay, so what I need you to do, I need you to pause the video. Okay, pause the video and try these. I'm not going to just sit here wasting time. Okay, so please pause the video, try these, we'll see how you do. All right, so we're back. Is the relation a function? Let's look at this one first. This will be number one, this will be number two. This is not a function. One, not a function. And the reason is 1 goes to -2 and 1 goes to 1. Okay, that's why it's not a function. Domain, list my domain, -3, 1, and 4. 3, 1, and 4. My range, those are my output values. My y is 3, -2, 1, and 4. Okay, we go to this one here. This one here is the relation of function. Yes, it is. So, yes, it is. Each x goes to only one y. These both have the same y value, and that's okay. 2, domain, -3, 2, and 3. Okay. And then my range, those are my output values, -2, 1, and 3. Okay? Hopefully it makes sense. One last thing I want to talk about. Well, it's probably two last things I want to talk about. The first is something you should be familiar with. They both probably are. The coordinate plane. The coordinate plane, okay? It looks like this. Okay, and this is my x-axis, and this is my y-axis, and this is my first quadrant, and this is my second quadrant, and this is my third quadrant, and this is my fourth quadrant. Starts here and goes counterclockwise. Okay, talks about all of your quadrants. And then we have the origin. This is your origin. Okay? And then the other thing I want to talk about, when we have this, we have a linear function or a linear equation. 5x plus 7, y equals 5x plus 7. Doesn't matter which one of these you have. The x is called your independent variable, and the f of x, or the y, is called your dependent variable. Okay? And the reason this is the case, all right, you can plug in any x that you want. The y, whatever you get for y, depends on what you plug in for x. So that's why they call this the independent variable and this the dependent variable. Okay? Dependent variable. All right? That, ladies and gentlemen, is section 2.1. I hope it made sense. If not, send me an email.